In this video, we're going to talk about the signs of trig functions and how we can calculate the trig values at any given angle given a couple restraints. So first, let's look at our Cartesian plane here, and we're going to go with our quadrants, remembering that we start in the upper right-hand corner for our quadrants and work counterclockwise out of this. That we have quadrant 1. What you will learn out of this is that all of your trig values, all trig functions, sine, cosine, tangent, and their reciprocal ones, are all positive. And also to remember in the first quadrant that your ordered pairs are always positive, comma, positive. When you jump over to the left here, we have quadrant 2. What we find here is that only sine and its reciprocal function, cosecant, is positive. All the rest are going to be negative. And to remind you that all ordered pairs are negative, comma, positive. Moving on to quadrant 3, the only trig function in this quadrant that'll be positive is tangent and cotangent. All the rest will be negative. Their ordered pairs are negative, negative. And then finally, quadrant 4, the only trig function here that would be positive, that would be cosine and its reciprocal function secant. And their ordered pairs down here are positive, comma, negative. So how can you remember which ones are positive? Well, there's a little mnemonic device that you can use here. All students take calc, using the first letters here. A for the word all means that all trig functions are positive. S for sine in the students. T for tangent and take. And C for cosine and calculus. If you can remember that, then you'll know which trig functions are positive in their given quadrants. Let's see how we can do this. Can we use the given information to find the exact values? And when I say exact, we don't want decimal values here. We want it written as a ratio of two numbers of the 5 remaining trig functions. And here's what you're given. We're given that the sine of our angle is 8 over 17. And we're only going to tell you that the tangent of your angle is less than 0. So here's what that means to you. 8 over 17, that means that your sine is a positive value. Tangent less than 0 means that your tangent needs to be negative. Let's go back to our quadrants here. Which quadrant would both of these rules fit? Where is the sine positive and where would the tangent be negative? Well, we know that our sine has to be positive in the second quadrant. All the others are going to be negative. That fits for tangent because tangent here is going to be negative. So therefore, we know that theta, our angle, has to be in quadrant 2 somewhere. Also, remember, we had sine defined as y over r. So we also know our r and our y values. We know that y is going to be 8, and we know that r is 17. There's only one value that we don't know, and that's the x value. So since we're stuck in the second quadrant, let's look at a visual here. The y value, that's the vertical component of the triangle. The r is the hypotenuse of the triangle, which is 17. We're going to have to find that x value. Again, hopefully you can see here with the visual that since we're at the second quadrant, the x value that we're going to end up coming up with is going to be turned into a negative. So let's apply our Pythagorean theorem. X squared plus 8 squared equals 17 squared. Go through a little algebra, we're going to get x squared equals to 225. Now normally here when you square root, x is going to equal a positive number. But since we're in the second quadrant here, our angle has to be in the second quadrant. The square root of 225, that was normally 15, we're going to make it a negative 15. Now we have everything that we need to know. We know our x value, we know our y value, and we know our r value. Let's plug in our ratios that we have. So cosine, we know as x over r. We'll put the negative 15 over 17. Doesn't simplify anymore, so we're done with cosine. Tangent, that's the y over the x. So that'll be 8 over negative 15. Doesn't simplify anymore, so we're done with it. Cosecant, that is the reciprocal of sine. So if you go back to the original function, 8 over 17, well, the reciprocal of that is going to be 17 over 8. Secant, reciprocal of cosine. So we have our cosine ratio, negative 15 over 17. We flip it, we get 17 over negative 15. And then finally, cotangent, that's the x over the y. That will give us negative 15 over 8. So we were able to use a couple of restrictions and go in and figure out the remaining 5 trig functions. We're going to try another example. Here we have cotangent is negative 4 and secant is greater than 0. These are reciprocal functions, so let's go back to their original. Well, cotangent, if we flip the fraction here, that would say that tangent would be 1 over negative 4. Secant, if secant is going to be greater than 0, then cosine has to be greater than 0. So let's look at their values. Right now, 1 over negative 4, that tells us that the value is negative. Cosine is greater than 0, so that tells us that it's positive. Let's go back to All Students Take Calc. Which quadrant would these both rules apply? Well, if you look, tangent has to be negative, so we know that it can't be in the third quadrant. But it does tell us that cosine has to be positive. There's only 2 quadrants that the cosine can be positive. That's the first and the fourth quadrant. But if we think back to what we said about tangent, tangent has to be negative. In the first quadrant, tangent is positive. So the angle must be in the fourth quadrant. Now that we know that, let's look at our visual here. And also see, what did I do here? Why did I put the negative sign with the 1, and I took it away from the 4? That's because we're in the fourth quadrant. Remember that our ordered pairs in the fourth quadrant are the x's are positive and the y's are negative. The way I have my ratio written right now for tangent is saying that the x value has to be negative, and that would take us out of the fourth quadrant. And also we're allowed to do that because no matter where that negative sign is, it's always going to be negative. So visual. Here's my triangle. I go right 4 for the positive 4 value of x. I go down 1 for the negative value of 1. And use the Pythagorean theorem. 4 squared plus negative 1 squared, that's going to give us 17. That's what r squared is equal to. So let's square root both sides. The value of r, the hypotenuse of this triangle, is going to be the square root of 17. But I have the 3 pieces of information that I need to do the rest of these problems. Go back in, let's find the sine. The sine value is y over r. So here is our ratio. We need to rationalize that fraction to give us negative 17, or negative square root of 17 over 17. Moving on to cosine, we need the x over the r, or in other words, 4 over square root of 17. Rationalizing that fraction will give us 4 square root of 17 over 17. Tangent, that we've already actually calculated the tangent if you think back to when we did our reciprocal. That's negative 1/4. And then cosecant, trick I have here is for cosecant, go back to your unsimplified fraction from sine. Go ahead and flip it. We have square root of 17 over negative 1, which would just be the negative of square root of 17. And then secant, we have the cosine of 4 over square root of 17, so that's going to give us square root of 17 over 4. And we have the 5 trig functions that we need for it. So when you get these types of problems, try to figure out where the quadrant would be for both of these so you can lock the theta into a quadrant. Maybe draw yourself a visual to see where that triangle is. And then once you figure out all 3 x, y, and r values, we can go in and figure out the trig ratios.